Welcome students. Now today we will start with exercise 2.4, question number 2 and 3. Now what's the question number 2? Use the factor theorem to determine whether gx is a factor of px in each of the following cases. Hope you all remember what the factor theorem was. Just to brush up, I will tell you what the factor theorem states was, if px is any polynomial with a degree n, then n should be greater than or equal to 1. First condition for the factor theorem was n should be greater than or equal to 1 and a is any real number. Okay, there were two conditions for the factor theorem. First, px is a polynomial of degree n where n is greater than equal to 1 and a is any real number. Then what does the theorem states? First point, x minus a is a factor of px. This was the first thing, that x minus a is a factor of px if and only if p of a is 0. Okay, and what the second thing was? It was just the reverse of it. So what's the converse of the factor theorem? If p of a is 0, then x minus a is a factor of px. So hope you all remember this. If you all don't remember, go back to my previous videos and see what the factor theorem is. Now what's the given question is, px is equal to 2x cube plus x square minus 2x minus 1 and gx is equal to x plus 1. So according to the factor theorem, the degree of the given polynomial px is 3. So it's obviously greater than 1. And we are given gx is equal to x plus 1. So in this question, by applying the remainder theorem, I can write x plus 1 is equal to 0, means x is equal to minus 1. Now I will replace x by minus 1 in the given polynomial. What does the remainder theorem states? Remainder theorem states that if something is a factor, like x plus a is a factor, then if I put the value like you are given in the remainder theorem, if you will remember the statement, in the remainder theorem we had if px is a polynomial and x minus a is a factor of that polynomial if and only if p of a is equal to 0. Okay, so you all remember, if I put that value a in the polynomial, then I get the remainder as 0. So if the answer comes out to be 0, p of a comes out to be 0, then you can say that x minus a is a factor. So same we are doing over here, we'll apply the remainder theorem. It's given x plus 1 is a factor, so I'll write x plus 1 is equal to 0, so x is equal to minus 1. So value of a over here is 1. Okay, value of a over here is minus 1. So now I will put the value, I'll replace the value of x is equal to minus 1 in the given polynomial. So what do I get? 2 into x cube, so it means 2 multiplied by minus 1 whole cube. Value of x is minus 1 because. Then plus x square, so instead of x square again I will write minus 1 whole square. Then minus 2x, so I'll write minus 2 multiplied by minus 1 because value of x is minus 1. Then again the minus 1 constant term I'll bring it down. So on solving this, I'll get the answer as 2 into minus 1, which is minus 2. Minus 1 whole square means 1 only. Minus 2 multiplied by minus 1 will give me plus 2 and minus 1. So the answer comes out to be 0. So remainder is 0, therefore I can say that x plus 1 is a factor of the given polynomial, means gx is a factor of px. Now let's move on to the second question. The value of px is x cube plus 3x square plus 3x plus 1. So this is also a polynomial with degree greater than 1. The degree of this polynomial is 3. So now again I will apply the remainder theorem. I'll write x plus 2 is equal to 0, means x is equal to minus 2. So I'll replace the value of x in the given polynomial. So instead of x, I'll write minus 2 everywhere. So x cube means minus 2 whole cube plus 3 into x square means 3 multiplied by minus 2 whole square plus 3 into x means 3 into minus 2 plus 1. So I get minus 2 whole cube. So minus 2 whole cube will be minus 2 multiplied by minus 2 again multiplied by minus 2. So the answer is minus 8. 3 multiplied by minus 2 square. Minus 2 square is 4. So 3 multiplied by 4 will give me 12. 3 multiplied by minus 2 will give me minus 6 and plus 1. So I get the remainder as minus 1. So remainder is not equal to 0. Therefore, I can say that x plus 2 is not a factor of x cube plus 3x square plus 3x plus 1. Now next question, this is the third part. Px is given as x cube minus 4x square plus x plus 6. Now again I will apply the remainder theorem. I'll write the given gx is equal to 0. So I'll write x minus 3 equal to 0. So this implies that x is equal to 3. I'll put the value of x is equal to 3 in the given polynomial. So I'll write x cube means 3 cube minus 4x square means 3 square plus x means plus 3 and plus 6. So on solving the powers I get 3 cube means 3 into 3 into 3, that is 27, minus 4 into 3 square is 9. So minus 4 into 9 is minus 36 plus 3 and plus 6. So answer I get is 0. So since the remainder is 0, I can say that x minus 3 is a factor of the given polynomial x cube minus 4x square plus x plus 6. Now the next question, question number 3. Find the value of k if x minus 1 is a factor of px in each of the following cases. If you are given that a number is a factor, that is x minus 1 is a factor of px, means by remainder theorem you can apply that x minus 1 is equal to 0, and if it is a factor then p of 1 will be 0. So let's see how we'll move on with the question. I'll apply the remainder theorem. X minus 1 is equal to 0, that means x is equal to 1. Now according to the remainder theorem, p of 1 should be 0. Okay, this is what it is given, it is a factor. So according to the remainder theorem or according to the factor theorem, both state same, that p of 1 will be 0. Okay, so I'll put the value of x is equal to 1. So what do I get in the polynomial? X square, instead of x square I'll write 1 square plus x is equal to 1 and plus k. So I'll keep the k as it is. So what do I get as answer as? K plus 2 is equal to 0, which means k is equal to minus 2. So value of k is minus 2. So now we move on to the second question. Again we have to find the value of k, where x minus 1 is a factor which is given in the question. So again I'll apply the remainder theorem. I'll write x minus 1 is equal to 0, which means x is equal to 1. Now again I'll put the value of x is equal to 1. According to the remainder theorem, p of 1 is equal to 0 if x minus a is a factor. So I'll apply it. I'll put x is equal to 1 in the given polynomial. So 2x square means 2 into 1 square plus k into x means k into 1 plus under root 2. So on solving this, I get 2 plus k plus root 2 means 2 plus under root 2 plus k. This whole should be equal to 0 by the remainder theorem or by the factor theorem, you would say. Both say same. So I get the value of k is equal to minus of 2 into brackets में 2 plus root 2. So value of k is minus in brackets 2 plus root 2. Third part, p of x is equal to kx square minus under root 2x plus 1. So again I will apply the remainder theorem. I'll write x minus 1 is equal to 0 means x is equal to 1. So according to the remainder theorem, p of 1 should be 0. So I'll put x is equal to 1, and what do I get? K of x square means k into 1 square minus under root 2 into x, which is 1, plus 1. On solving this, I get k minus root 2 plus 1. So the value of k is equal to 0. By the remainder theorem or the factor theorem, I'll write this should be equal to 0 because this is a factor. X minus 1 is a factor of the polynomial. So k is equal to under root 2 minus 1. Now the fourth part, p of x is equal to kx square minus 3x plus k. Now I will apply the remainder theorem. X minus 1 is equal to 0 means x is equal to 1. So according to the remainder theorem, p of 1 should be equal to 0. So I'll put x is equal to 1. We get p1 is equal to k into 1 square minus 3 into 1 plus k. I'll solve this. I get as k minus 3 plus k. So I'll equate it to 0. So I'll get 2k minus 3. So I'll transpose it. Then I'll do cross multiplication. So value of k comes out to be 3 by 2. With this, we've completed exercise 2.4, question number 2 and 3. In the next video, we will discuss with question number 4. Thank you, students. Complete your work in your copies and don't forget to practice maths daily.